Hello everyone, my name is Subrata Samanta and I am from IIT Kanpur. So I am your tutor for the physics subject. So in the previous class we will discussing about the electric field on the axis of a rod. Okay. So we will continue to calculate continue this in this class. So where we left that the charge of the charge of a small segment dx prime is dq becomes lambda times dx prime, where the lambda is a uniform charge density, this q over L. So then the electric field and the directions of the electric field E minus I cap, right. So this is the direction. Okay. So the contribution of the electric field E vector due to dq, the electric field E due to dq at point P, this becomes dE 1 over 4 pi epsilon naught dq over r square times r cap. So here the r cap and the directions of the electric field is, so in the previous class we discussed that the directions so the directions of the electric field is negative x axis, right. So minus I cap, right. So this r cap becomes minus I cap. Okay. So r cap becomes minus I cap in this specific case. Okay. So 1 over 4 pi epsilon naught and dq is, so dq becomes lambda dx prime, right. So okay, so 1 over 4 pi epsilon naught lambda dx prime over x prime square minus I cap. So here r is basically x prime. Okay. So if you look into the figure, so this one is x prime. Okay. The distance from the small segment dx prime to the point where you calculate the electric field, okay, and that is x prime. Okay. So now we replace lambda by the total charge q. So 1 over, so this one becomes minus 1 over 4 pi epsilon naught q over L dx prime x prime square I cap. So now in order to calculate the net electric field, we have to integrate over the entire length of the rod. So the net electric field so integrate over d, basically 1 over q over 4 pi epsilon naught times L, then integrate. Okay. So integrate over dx prime x prime square then I cap, right. Okay. So now what is the limit of the integration, right. So now so if we look into the figure, we see that the rod start from x0, okay, at a distance from P, and the length of the rod is L. So the limit of the integrations x0 to x0 plus L, and that is cover the entire length of the rod. Okay. So since there is only x component of the electric field is there, so because I cap. Okay. So basically the Ex, we are not writing in terms of since that here the unit vector is not r cap. Okay, so r cap basically minus I cap. So the electric field becomes q over 4 pi epsilon naught L. Okay, and the I cap is taken outside. Okay, and the integral becomes a scalar. So basically in the previous class we discussed that Ex, okay, So, projecting of the electric field along the x axis. So, minus q over 4 pi epsilon naught and the integral part, and then I cap dot I cap. Okay. So, this is the integral part and I cap dot I cap. Okay. So, this one is 1, right. So, this I cap dot I cap basically 1. Okay. It gives 1. Okay. So, therefore, the only x component of the electric field are non-zero, okay, and other components have become 0. So, that is why you are just writing in terms of vector form. Okay. So, then I cap taken outside of the integral, and so solve the integral and put the limit. So, we get 1 over x naught minus x naught plus L. Okay. So, then this becomes minus 1 over 4 pi epsilon naught q L times x naught times x naught plus L, okay, and here is L. So, L cancel, okay, both the numerator and denominator. So, the left with this. So, this is the expressions of the electric field at a point on the axis of a rod, okay, at a distance x naught from the end of the rod. Okay. So, at the again remember that the x naught is the distance of the point from the end of a rod, okay, end of a rod. Okay. So, the electric field now, if the point P is very far away from the rod, okay. So, in this case the x naught is very greater than L, right, the length of the rod. So, then the above expression becomes, so for any arbitrary x naught we get E minus q over 4 pi epsilon naught x naught L plus x naught times I cap. So, now if we use this approximation, okay, so then the electric field becomes A, okay, minus q over 4 pi epsilon naught then x naught square. Okay. So, basically L plus x naught, in that limit x naught very greater than equals to L, L plus x naught is nearly equals to x naught, okay, and we got this. So, this is basically a electric field, okay, due to a point charge with a total charge q. So, if we calculate the electric field at far away from this rod, so it basically looks like the point charge of total charge q, okay, is lambda times L. Okay. So, this one is expected, okay, and the directions, okay, and the direction is that again negative y x axis, okay. So, that is why there is a negative sign, okay. So, this one is expected, okay, and so at the end you must have to check the limiting case, okay, and so this specifies that your result correct or not, okay, for a arbitrary x naught. So, we compare the two expressions, okay. So, this one and this one, okay. We will see the difference between of a point charge distribution and a continuous charge distribution, okay. So, here is a x naught times L plus x naught, here is a x naught square, that is the difference. Okay. Similarly, if we calculate the electric field on a perpendicular bisector, okay, so not on the axis of a rod, but the perpendicular of the at a distance from the perpendicular of the rod, okay. So, the electric field, and it becomes interesting that electric field on the perpendicular bisector So again we can consider a non-conducting rod, a non-conducting rod of length L, okay, and with a non uniform charge density lambda, okay, and total charge q, as same as before. So now, but in that case we calculate the electric field. So if we consider a rod here, okay, so the length of the rod is L, okay, and we calculate the electric field at a point perpendicular to the rod. So in the previous case we calculate the electric field at a point on the axis. So now we calculate the electric field at a point perpendicular to the rod, okay, perpendicular axis, at a point perpendicular to the axis to the rod, okay. So the distance from is y from a point, let us say O. So we denoted this point O, okay. So you have to calculate the electric field at point P. So we first consider a small segment, okay. So let us say consider a small segment here, okay, yeah, at a distance x prime from O, okay, and the length of the segment becomes dx prime, and the distance from this segment to the point P so this distance r prime, and from this point the end of the rod, okay, this point to this, if we draw another, so this is the distance r, then this distance is L by 2, okay, this whole distance is L and this distance L by 2, right, and the angle, so this makes an angle theta prime, okay, theta prime, and this one makes an angle theta. So again the charge distributions is a uniform, okay. Then the lambda, so lambda is q over L, okay, and the charge, the electric charge of a small segment dx prime is dq, so lambda times dx prime, okay, and the electric field due to this small segment with charge dq, the electric field due to charge segment dq dE 1 over 4 pi epsilon naught dq over r prime square, right, okay. Just put into this the form of dq, so lambda times dx prime and 4 pi epsilon naught. Now what is r prime? So in this figure the r prime basically x prime plus, so if we use Pythagoras theorem, then r prime square x prime square plus y square, and r square y square plus L by 2 square, okay. Yeah, L by 2 square. So this is basically x prime square plus y square. Okay. Now we use symmetry argument. Okay. So that is basically, so let us draw the figure again. So if the x axis, okay, so let us consider the rod, okay, and the length of the rod is L, okay, and the midpoint is O. Okay. So the distance the point P, place it at the off axis point P and the perpendicular distance from the center O, okay, and the distance is basically y, okay, and we consider a small strip here, the charge is dq at a distance. So from this charge distribution, the electric field at point P basically this, and the direction is this case d e vector, right. So let us say consider d1 vector. Now similarly, if we consider a charge distributions in the opposite side, okay, and the similarly the electric field vector at this point P is d e2 vector, right. So now this is a vector quantity, so we have a two component, okay. So one is so d e1 have a component along the y axis, and this one is along the x axis, and d2 also component along the y axis and along the x axis, right. So we choose a, so this is I cap, this one is j cap, okay. So the axis, in this axis, the if we split the d1 into two components, one is the x component, another is the y component, similarly for the da2. So it is easy to see that the x component cancel each other of the two field, okay, using symmetry argument. So this one is cancel, okay, so this one is cancel each other, okay. So using symmetry principle, so using symmetry principle, or the symmetry argument, so using symmetry argument, the x component so that the x component of the electric field vanishes. Since that the magnitude of d1 and d2 are same, but the directions is opposite, okay, so that is why they cancel each other. Magnitude of d1 is the same as d2, but the direction is different, so that is why it cancel each other, and that is clear from the symmetry argument. So similarly, if we calculate the y component of the field, okay, so dEy, the y component of the field, okay. So dEy is basically dE times cos theta, right. So this implies that Ex is 0, and so we calculate d times cos theta. Now how to calculate d? So d already we know that yeah, so here we calculate d, so just plugging into here, so 1 over 4 pi epsilon naught lambda dx prime x prime square plus y square. Now what is cos theta? So here theta is not, so we consider it theta prime, right. Yes, so this one is a theta prime, so this is angle theta prime, this is cos theta prime, right. So now cos theta prime, y divided by square root of x prime square plus y square in order to calculate Ey, we have to integrate over the entire length, right. So 1 over 4 pi epsilon naught minus L by 2 to L by 2, and then just put lambda y dx prime over x prime square plus y square that whole to the power 3 by 2. So, if we calculate this integral, okay, I am left this integral. So, you calculate in your home. So, this is your homework, and we finally got Ey 1 over 4 pi epsilon naught 2 lambda sin theta over y. Okay. So, 1 over 4 pi epsilon naught 2 lambda over y times L by 2 to y square plus L by 2 that whole square. So, note the difference between theta and theta prime, right. So, here is theta, and in the previous case this is a theta prime. Okay. So, we finally got this. So, check this result, okay, by solving this integral. Okay, it is easy to show, okay, and yeah. So, I hope you can do this integral and verify the results that is given. So, okay, we will see in the next class. Thank you.